So this video is a follow-up of the rules of exponents part 1, where I talk about the product rule or the multiplication rule and the quotient rule of exponents. Okay, the next rule that I'm going to talk about is going to be the zero exponent rule. So sometimes we can have the number 0 as an exponent, and there is a way to deal with this. Okay, so we have something like x to the power of 0. The result of anything to the power of 0, it's always 1. 1 as in coefficient, okay, as a big number, not as an exponent. This is not the same as this, right? Or as x to the power of 1. These are not the same things, okay? So anything to the power of 0, it's always 1. This is a way to say it cancels out, okay? So it cancels out, it disappears, there's a 1. And you don't have to put the 1 unless there's nothing in there. So if you have a, let's say, an x to the power of 0, x to the power of 0 divided by 2, then you have to place a 1, right? Because you cannot just leave the fraction by itself, the numerator with nothing in there. Okay, so anything to the power of 0 is going to be equal to 1. Okay, so this next example, the only thing that I change in is the variable m to the power of 0. It's the same thing, that's going to be equal to 1. And it can also be a number, 14 to the power of 0, it can be 10 to the power of 0, it can be 5 to the power of 0, it can be 1,000 to the power of 0. The result is always going to be 1. And it doesn't matter how complicated your expression is, right? I have a lot of letters and variables and exponents in there, right? But all of this thing is to the power of 0, so all of that thing is going to be equal to 1. So where I see that we run more into problems in this zero exponent rule is when we have some negatives in front of the coefficients. So let's see what the difference between these two situations are. So I have some numbers that are to the power of 0. So what would the result be for the first operation? I want to say that your first guess is going to be 1, right? But this is going to be wrong. Okay, you have to be careful. This exponent, and it works for every exponent, but this exponent only applies to whatever's in front of it. So you have to be very, very careful. So that 0, it's only in front of the 4. So that negative sign is not involved into the exponent. So that's a 4 to the power of 0. So that's the only thing that's going to become 1, right? I still have some other operations or some other numbers in front of that 4 that have to stay. So that is very, very important. Okay, so the exponent only applies to whatever's in front of it. If you want that exponent to apply to several things, that's why you use parentheses. So in this case, that 0 applies to the whole thing inside the parentheses because what's in front of this 0 is a parenthesis. So it applies to the whole thing inside the parentheses. Okay, but in this other case, I don't have a parenthesis, so the exponent only applies to whatever's in front of it, just the number. Don't worry about the sign, or don't worry about anything else that's in front of it. Okay, just to the number. So in this case, I'm not gonna do the subtraction yet. I'm still gonna leave that negative sign in here. We're not doing anything to that. And then I have 4 to the power of 0, which becomes 1. So can you see why this is going to be negative 1? Okay, because exponent is not applied to the negative sign. If I wanted that exponent to be applied to the negative sign, then I will have it written something like this over here, right? That 0, that exponent of 0 applies to the whole thing inside a parenthesis, the whole thing. So the whole thing is going to become 1. So this is the difference between those two results. So you have to be careful. Okay, for every rule of exponent that I already talked about and then that we're going to talk about, the exponents only apply to whatever's in front of them, just in the very front of them. Okay, if it's a number and a sign, you will have to use a parenthesis like this example on the bottom. Okay, if it's just a number, then it's just a number, right? This is the only thing that's applied. So this is the zero exponent rule. Anything to the power of 0 is going to be equal to 1 or it cancels out. Okay, so the other rule that I'm going to talk about in this video is going to be the negative exponent rule. And this is if we're simplifying an expression and we're left with negative exponents, we have to get rid of those exponents, okay? So we cannot have any negative exponents in the results. So for example, if I have something like x to the power of negative 2 in the result, it means I cannot leave that x to the power of negative 2. And what we're going to do to get rid of a negative exponent is get the reciprocal of the expression that has exponent. So everything that has that negative exponent is going to become a its reciprocal, and the exponent is going to become of the opposite sign. In this case, the exponent is going to become positive. So I'm going to get the reciprocal of the expression, 1 over x, and the exponent is going to keep its number, but it's going to change its sign. Okay, so if it's on the top right now, as it's written, you can think about it as x to the power of negative 2 over 1. So this x to the power of negative 2, or this x migrates to the bottom. So now it is on the bottom, and all you have to do is change the sign of the exponent. And this works the same for numbers or letters that have a negative exponent. So it goes to the other side, okay, from top to bottom or from bottom to top. Because of my starting example, it can look something like this, right? 1 to the power of x minus 2. If I want to, x to the power of negative 2. If I want to get rid of this negative exponent, I have to get the reciprocal of whatever has the negative exponent. In this case, this x to the power of negative 2 is in the bottom, so it's going to migrate to the top. Comes x to the power of 2 on the top. Of course, I still have that 1 from the top right, but it makes no sense to write 1x to the power of 2. You can just leave the x to the power of 2. Okay, so this is the negative exponent rule. You get the reciprocal to get rid of the negative and make it a positive. Okay, remember, for these two rules and for every rule, the exponents are only applied to whatever's in front of them. So only whatever's in front of the exponents is going to migrate, is going to become 1, it's going to be multiplied or divided, right? So let's see the next expression over here. So that's 10 divided by x to the power of negative 2. The negative exponent rule says that if I have any negative exponents, I can get the reciprocal of whatever has a negative exponent. Okay, so this x is in the bottom. That means that the x has to go to the top. And can you see that that 10 is not going to go anywhere? That doesn't have a negative exponent. The only thing that's going to happen is that I'm going to bring up, I'm going to draw my division line just so you can see that the x is going to migrate up. From the bottom goes up. It keeps the exponent, but it changes the sign of the exponent. So that's going to be my result, 10x to the power of 2. Okay, only whatever has exponent migrates, everything else has to remain where it is. Okay, now this next example over here, 5x to the power of negative 3. I have to get rid of that negative exponent. First, I have to decide what has a negative exponent. And if you say that 5x has a negative exponent, you're going to be wrong. Because remember that the exponent only applies to whatever's in front of it, not the numbers, not anything else, not signs, etc., etc. Only whatever's in front of it. If I wanted that exponent to go to the 5, the expression will be written something like this. Then that negative 3 goes to the whole 5x. But in this case, since I don't have any parentheses, that means that only the x is going to migrate. So this 5 is going to stay on the top. We're not doing anything to that 5. And since the x to the power of negative 3 is in the top, now I'm going to send it to the bottom. And I change the sign of the exponent. That's the only thing that I'm changing. Okay, so for the next example, negative 2x to the power of negative 10. Again, I have to identify what has a negative exponent. And the only thing that has a negative exponent is x. This 2 over here, that's not a negative exponent. It is a negative sign, but it's not going to migrate because this is not a negative exponent, because these are rules for exponents only. Okay, so that negative 2 is going to stay where it is, which is in the top right now. And then the x to the power of negative 10 is going to migrate from the top to the bottom. So it goes to the bottom, x, and I change the sign of whatever has a negative exponent only to a positive. And that should be my result, negative 2 divided by x to the power of 10. Now, a common mistake that I see for the next example, I have negative x to the power of 5. I see people trying to do this. But the mistake in here is that this is not a negative exponent. Right? This looks like a positive exponent to me. That's a positive exponent, that's a positive 5. The negative sign, it's in front of the whole expression, so a negative sign is like a big number. So if you do this transformation, you're going to be wrong. Okay, this is going to be wrong. In reality, this expression is already simplified. We cannot do anything else to this. Okay, so if the negative sign is in front of the letter, you're not going to do any migration from top or bottom, only if the negative sign is in the exponent. Then you take that expression you send it to the bottom. Okay, only if this is on the exponent, then you send it to the bottom. Or if it's on the bottom, right, then you send it to the top, but only whenever it has a negative exponent. So this example on the bottom, there's nothing we can do. There's no negative exponents, so we should be perfectly fine like this. And I give you this example because this is a common mistake. People try to do the negative exponent rule in this case because they see a negative sign and they're getting used to all of these rules, right? But negative signs, they are only subject to the negative exponent rule if they are in an exponent, okay? So this is the second video. I'm gonna upload a third video about some other rules that we're gonna talk about also.